In this lesson, you'll learn about volume and surface area. For this first problem, we have a cone inside of a cylinder. They are sharing the same base, and the vertex and the top of the cone are on the same plane. So the right cylinder has a height of 9.8 feet, and the cone inside the cylinder has a volume of 217 cubic feet. The question is, what is the radius of the cylinder? Let's put our 9.8 feet over here right on our diagram, and we're looking for this radius here. So I'm going to go ahead and mark that with an R. We know that the formula for the volume of a cone is 1/3 times the area of its base, which in this case is a circle, and all cones have a circular base. So that'll be pi r squared times the height of the total cone. And we've been given all of these values except the radius of the cone. So let's go ahead and fill those in. We know that 1/3 times pi times the radius squared times our 9.8 feet is going to give us about 217 cubic feet. And if we solve for r squared using 3.14 for pi, we get approximately 21.156. And if we take the square root of both sides and round to the nearest tenth of a foot, we get that the radius of the cylinder is about 4.6 feet. Now let's take a look at another one. A rectangular pyramid has a length of 18 yards, a width of 9 yards, a slant height of 15 yards, and a total height of 12 yards. And we're being asked to find the surface area of the pyramid. So we'll begin by doing a sketch, and it doesn't have to be anything fancy. You just want to put something down on your paper so you can mark your dimensions, see what you have, and see what you're looking for. Since we're working with a rectangular pyramid, we need a rectangular base. So I'll begin with a slanted rectangle or a parallelogram. We'll put a point at the top and then connect the point to each of the vertices of our base. Now we're given that the length is 18 yards, the width is 9 yards, and that there's a slant height of 15 yards. Now remember, the slant height is the outside height, making a 90-degree angle with one side of the base. So this piece here is going to be 15 yards, and usually that's denoted by L in a formula, or you could write out the word slant height. We're also given that the height of the total pyramid, the inside height, is going to be 12 yards. Now that's the distance from the highest point down to the base. It makes a 90-degree angle with the base. So this piece in here is 12 yards, and typically that is denoted by H. Now we're being asked for surface area, and one of these values has nothing to do with surface area. The inside dimension, the inside height, has to do with volume, not surface area, so we can get rid of that. We needed the 15, the 9, and the 18. So now let's take a look at the formula for the surface area of a pyramid. The formula for the surface area of a pyramid is 1/2 times the slant height times the perimeter of the base plus the area of the base. So filling in the values that we have that the surface area is going to be 1/2 times the slant height, which we said was 15 yards, times the perimeter of the base, which is 2 times 18, plus 2 times 9. And then that product needs to be added to the area of the base. And since the base is rectangular, the area of the base is just going to be 18 times 9. And all of this gives us 567 square yards for a surface area. Now let's try another. For our last question, we have that Kennedy's hot water tank is 4.8 feet tall and has a diameter of 2.8 feet. The question is, how much water is in the tank when it's completely full? The first question we should be asking ourselves is this a surface area problem or is this a volume problem? It's going to be a volume problem because we're talking about filling up the inside of the tank. So let's go ahead and do our sketch of the cylinder. We've got a height of 4.8 feet, and then we've got a diameter of 2.8 feet. But since we're not going to use a diameter in our calculation, let's go ahead and take half of that and mark that 1.4 feet for our radius. The formula for the volume of a cylinder is going to be volume equals pi r squared, that's the area of our base, times the height of the total cylinder. When we fill in our values, that's going to give us pi times the radius squared, or 1.4 squared, times 4.8. And if we use 3.14 to approximate for pi and round to the nearest tenth of a cubic foot, we're going to get 29.5 cubic feet. So the amount of water that Kennedy's hot water tank is going to hold is 29.5 cubic feet of water. Now you know a bit more about volume and surface area. See you next time.